Proof starts with a right angled triangle, as you might expect. And note in this right angled triangle, the blue angle and the yellow angle must add up to 90 degrees because the other 90 degrees in the triangle is taken up with the right angle. We take exactly the same triangle and place it there. Another triangle, exactly the same, place it there. And a fourth triangle, and we place it there. So we've got a space in the middle. So imagine those are 4 bits of carpet covering a wooden floor. Now note, remember what I said? The yellow angle and the blue angle must add up to 90 degrees, which means along this straight line here, the angle between the yellow angle and the blue angle must be 90 degrees because they must add up to 180 degrees. Similarly over here, the yellow and the blue add up to 90, so the missing angle in the middle must be a right angle, and so we have 4 right angles. Therefore, the space in the middle, as we can see, each side is a length C, 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 so this is definitely a square in the middle, and the area of the wooden floor therefore equals C squared. However, if we take exactly the same floor and pieces of carpet and we slide them around like that, and like that, the area of carpet is the same, which means the area of wooden floor is the same. And as we can see, the areas of wooden floor, there are 2 of them, A squared in the bottom right hand corner, and then B squared, which is the main area of wooden floor you can see. So consequently, those 2 wooden areas must equal C squared. Consequently, A squared plus B squared equals C squared. And that's Pythagoras' theorem. So we have a circle, and to that circle we're drawing a tangent. And tangent comes from the Latin meaning to touch. So the tangent just touches, it doesn't cut through the circle. And there's the point where the tangent touches the circle, and from that point we're going to draw a chord, and that chord separates the circle into 2 regions called segments. So from the screen there we can see we've got a yellow segment at the bottom and a green segment at the top. Between the chord and the tangent we've marked in angle A, and that angle A rests over the yellow segment. Now from the same chord, in the other segment, the alternate segment, we form an angle at the circumference. And the theorem tells us that the angle at the circumference is equal to the angle between the tangent and the chord. So that's quite a long theorem to write down, but we just have to learn this because it's really important. The maths we've shown previously tells us that circular motion is equivalent to simple harmonic motion in 2 directions. When we measure the displacement from the x-axis and the displacement from the y-axis of an object which is performing circular motion, we see that the motion in the x direction is simple harmonic and in the y direction is simple harmonic, and we can visualize it like this. That pink spot is the displacement as measured from the blue y-axis, and the blue spot is the displacement measured from the x-axis. So as the red spot is performing circular motion, its displacement from each axis is simple harmonic motion. If we observe the red spot performing circular motion, in the x direction it's starting from the end of the oscillation, moving to the center and then back again. Consequently, we measure its displacement using the cosine curve. However, in the y direction, the red spot is starting at the center of the oscillation, and we will be measuring its displacement using the sine curve.